Dear aspirants, welcome to my channel. This is an model question paper 2 part D 5 marks questions. Describe a type of chains and their applications. So one is a metric chain. The length of the chain is 20 to 30 meter and links which is consisting of 20 links, and each 5 meter there is a brass marking will be there. Application for this we can use it for common in modern surveying, and we can use suitable for engineering works and general land works. We can use this type of the chain. Next will be an engineering chain. It is an length is 100 feet, 100 links in each 1 feet length. And so applications, the engineering chain we can use it for measurement of feet, and we can use it for measurement FPS system. We can use it for another country. Next will be in Gunta's chain. It is a length is 66 feet, 100 links. So which we can use it for land survey, cadastral surveys, and we can use for area calculation. 1 hectare is equal to 100 square meter of the chain we can. Next will be in revenue chain. The length is 33 feet. One link will be 16 links. So we can use it for revenue engineers, and we can use it for village and agricultural measurements, land measurements we can use. So band chain or steel band, it's like a steel. It is consisting of material which is an steel ribbon. So length will be 30 meter or 20 meters, and width thickness is 12 to 16 mm. See, application for steel band which we can use it for high accuracy requirement, and we can use it for precious engineering works. So next will be an what is whole circle bearing and convert reduced bearing to whole circle bearing. There is a 3-4 problems as given. So whole circle bearing nothing but it is a north from clockwise direction towards the north direction. It is vary from 0 to 360 degree, nothing but it is an whole circle bearing. It will start with 0, it will come back to again 360 whole circle bearing, it will come back to same 360. There is a formula for calculation conversion of reduced bearing into whole circle bearing. The first rule, it is north towards north, theta towards east. It is whole circle theta. You have tried whole circle bearing is theta. So south theta towards east, whole circle bearing you have to do 180 degree minus theta. South towards west, whole circle bearing is 180 plus theta. North towards west, whole circle bearing is 360 minus theta. This formula, if you know, you can solve the problem. It is north towards east, the whole circle bearing, whatever angle is given, theta 45 degree. Same way, south 60 degree to towards east is south 60 degree to towards east. You have to do 180 minus theta, 180 60 degree, you will get a 120 degree. Next problem will be north 60 degree towards west, north 60 degree towards it, according to formula 360 minus theta. So 360 minus theta, if you do 330 degree. Same way, south 75 degree to towards west. Here south theta to west, one whole circle bearing is equal to 180 plus theta. So I have made 180 plus theta is equal to 75 degree. So I will get 225 to 55 degree will be an answer for this. It is described procedure for fly leveling. So in the fly leveling, we have to find first, we have to fix the instrument, you have to take back set and you have to take the foresight. This is an foresight. Again, if you shift the instrument where you are taken back set, where you are taken foresight, that will be an back set. Next will be an foresight. This is the diagram for that. Okay. So fly leveling, to find the difference elevation between 2 point, benchmark quickly, that is we call it as in fly leveling. In the fly leveling, you have to fix the instrument near the benchmark. You have to take the backside near the benchmark, and based on the formula height of instrument you have to calculate. If you know the RL of the benchmark plus backside, you can calculate the height of instrument. Same way foresight meter is equal to, again you have to take the foresight of the next point. So RL of the point you have to calculate, RL is equal to height of instrument minus foresight. You can, and shift the words forward, takes same process will be repeated until the complete procedure will be takes place. So this is how to draw neat sketch. So draw a line on a ground. So benchmark and temporary benchmark you have to mark, and instrument of the point, backside towards the benchmark, and temporary benchmark towards the point. So this is the formula for simple leveling. They given readings. The always first reading you have to write it in a benchmark point, where you have to write benchmark point, and last reading you have to write it in the where you are going to write the backside format. So I have written and RL. I will show you the diagram. So make a tabular column, station, backside, foresight, or backside, raise, fall, and RL. Okay, so station you are right, backside I have written 0.2, and this is an backside for foresight, all they are written, backside and foresight reading all they are written in one tabular column. Okay, and rise we have to find the difference between this. You got a positive value, you have to write a fall, positive value fall, positive value fall. You got a negative value, write it in rise, negative value write it in the rise. 150 will be there, so 150 you have to do minus of that, minus of, so 0.47 you will get 147, this minus and this you will get 148. Fall will be how to make it minus, this minus do you will get, after that this plus you have to do plus for rise. Okay, so after that this plus rise you will get a final answer for 149.8815. Okay, so here backside and for summation of foresight you have to minus that, you should give, got is 0.185. same way summation of rise and summation of fall you have to make it. So here also you will get this value if you substitute these two values, if you minus that summation of that 0. These two value you get same, then only your answer is correct. And one more check, 5 last RL and first RL if you do you will get a difference, same difference. So if you apply for final check, if you apply for year you should get all the values will be same, so then only your answer will be correct. Okay, next describe the various types of offset. One is an perpendicular offset, it is an exactly 90 degree, this is we can call it as an 90 degree, exactly 90 degree chain. So you can measure, accurate measurement requirement, we can commonly use for accuracy purpose, we are using in oblique offsets, perpendicular offset. Coming to the oblique offset, it is an not exactly 90 degree, it may be more than 90 degree, less than, that is we call it as a more than 90 degree, this we call it as an oblique offset. So it is, you cannot be difficult for perpendicular offset, uneven ground surface, this method we can use. This short offset we can use it for smaller areas less than 15 meter. It will be an perpendicular type of an offset. We can use it for smaller area. The area will be small. There we can use. It is because it is used for smaller area distance. Prefer for a survey works. We can use this type of offset. Next will be long offset. The offset will be more than 15 meter. That whatever 90 degree offset we can take should be more than shorter offset. We can use it for this chain survey, lesser accuracy purpose we can use compared to shorter offset. We can, where we can't use shorter offset, there you can use it for longer offset. Next will be explain magnetic declination, how it will be affected. Magnetic declination, it is an angle between true north and magnetic place that we call true north, which you can take it from geodetical north pole. It is show the magnetic north we can use for using a direction of the compass. So there is a type of declination, one is east declination and west declination. In east declination it will show true north direction, it is always positive. So if you coming to the west direction, it will show magnetic declination is true west, and it will be we are considering as a negative. So how it will compass reading will be affected, always it will be affected by magnet. It is how it will be affected, the compass always magnetic bearing, it will not true bearing. A reading will be affected by declination. So we have formula for calculation true bearing. True bearing is equal to magnetic bearing plus or minus declination. So the rule will be, and declination is east, true bearing will be magnetic bearing plus declination. If the true bearing is west, true bearing is magnetic bearing minus declination, you have to take negative value for that. And why it is important, the declination should be considered based on the error of the surveying. So if the map is accuracy map, direction fixing and navigation, it should be necessary. So this question already so many previous videos I have explained. So characteristics of contour, nothing but imaginary line, it is having equal elevation of the ground surface. Contour we can represent like this. This we call it as an contour. We are representing diagram, it is an equal elevation. Characteristics of contour, the contour points, it is having equal elevation, it is not, does not intersect each other, it continuous. It is having a continuous closed lines. It is a space between indicative. It will be an close. It will show steep. It will be an wide. It will show gently. It is indicate uniform slope and uniform space. Okay, slope and space indicate contour. the contour is perpendicular to the direction of the maximum flow of the line, and water flow will be perpendicular. You can write an example. Contour lines cross valleys and rigid differently. The V-shape pattern upstream, and rigid we can show the downstream. V-shape pattern upstream like this is, and V-shape pattern in the downstream it will show like this, downstream rigid patterns like this. Okay, and it is high contour represent higher elevation, so it will be increasing in hilly area. Hilly area will be in high, will be hilly area high, and valley will be decreased like this. See more information, please subscribe my channel and share support. Part D 10 marks question, I'm going to upload another video. Thank you.